Okay, so let's dive into something that's pretty crucial these days, evaluating AI
hmm
and specifically all those chatbots that we seem to be interacting with more and more, you know?
Yeah, the question is, how do we really evaluate how smart they are,
Right.
right? Like, how do we go beyond just can it hold a conversation?
Right, because like booking a flight online,
Right.
that's not just a one-shot deal, right? You might change dates,
Yeah.
add a meal, ask about baggage. It's multi-step. And that's where the research that you've gathered suggests that these traditional evaluation methods kind of fall short.
Yeah, they do. They really do because it's like we've been testing a car, on a treadmill instead of an actual road.
Uh-huh.
We need a more sophisticated approach, which
Yeah.
is where this framework called IntellAgent comes in.
So IntellAgent wants to be the ultimate test track for chatbots, huh?
That's a good way to put it.
The research dives into how it tackles this by using AI to actually build the evaluation scenarios.
Right.
It's pretty meta, don't you think?
It is. It's very meta.
Using AI to test AI.
Well, it's a necessary evolution, I think, because we're dealing with these large language models, these LLMs that are increasingly complex,
Mhm.
um, capable of planning and even refining their own actions. So static, manually created scenarios just don't cut it anymore.
And the core of this seems to be this idea of a policy graph.
Right.
Sounds kind of intimidating, to be honest, but the research lays it out as this foundation for creating these dynamic challenges. So,
Yeah.
what is that?
So imagine you have like a flow chart for a really complex customer service process, right?
Okay.
And each box in that flow chart represents like a rule or procedure.
Mhm.
So things like verify the user's identity or modify an order or process a refund. And the connections between these boxes represent how likely those procedures are to happen together in a real interaction.
So instead of just testing if they could verify the user,
Right.
you're looking at, okay, what happens if they have to verify the user and then modify an order?
Exactly.
How does that sequence actually play out?
Yeah. How does that play out in a sequence and what are the chances of that happening together?
Got it.
So that's what the policy graph allows you to do.
Okay, so we got the rules of the game laid out in this policy graph. Now we need someone to actually play the game, right? And that's where the virtual user agent comes in, according to the research.
That's exactly right. Yeah.
So tell me about that.
So think of this virtual user agent as like a very sophisticated chatbot
Okay.
that is designed to test the chatbot that is being evaluated.
Okay.
And so it's programmed to be a little bit unpredictable, just like a real person would be.
So it might ask questions out of order or
Yeah.
change its mind halfway through or
Exactly. And even try and pull a fast one on the chatbot.
try to trick it.
Yeah, trick it.
Okay.
And all the while this is all happening, IntellAgent is meticulously tracking every single action that the chatbot takes and checking if it's adhering to the policies that are outlined in that policy graph,
Yeah.
accessing the right data,
hmm
and providing accurate information.
So it's like having a referee scrutinizing every move of this game.
Yeah, a very precise referee.
And after this virtual interaction plays out, we have the dialogue critique component.
Right.
So this is where the verdict's delivered, right? Is it just a pass or fail, or is there more nuance to it than that?
There's definitely more nuance to it. I think of it as like a very detailed performance analysis.
Okay.
So the dialogue critique component, it analyzes the entire conversation. It highlights where the chatbot excelled
Mhm.
and crucially where it stumbled.
So you could say, okay, you did really well here, but you really messed up here.
Yeah.
But why is that level of detail so important?
Because we're not just aiming for chat box that can, just string together grammatically correct sentences, right? We need to know, can we actually trust these systems to handle really complex tasks? And
Right.
consistently, especially when faced with maybe an unexpected, turn in the conversation.
And one of the research papers actually dives into some initial results from using this IntellAgent system. And one thing that jumped out at me is how much emphasis they put on comparing these findings to existing benchmarks.
Right.
So why is that so important?
Well, it's crucial, right? Because you have to make sure that this new approach is actually valid.
Yeah.
So they specifically compared IntellAgent to this benchmark called DoorBench,
Okay.
which uses real-world data for evaluation.
So it's like checking its answers against the textbook.
That's a good way to put it.
Okay.
The real-world textbook.
And what did they find?
So they actually found a very strong correlation
Wow.
between IntellAgent's findings and the real-world benchmark.
So even though IntellAgent's using this
Yeah.
AI-generated scenarios,
Yes.
it's producing evaluations that are consistent with what you would see if you were to, let these chatbots loose on real people.
Exactly.
That's pretty powerful.
And that was the main takeaway for me too, that this strong correlation suggests that IntellAgent could potentially be a much more efficient and scalable way
Yeah.
to evaluate these AI systems.
Because gathering and labeling real-world data,
It's a nightmare.
it's a huge undertaking.
It is a huge undertaking.
And so if you could just generate this synthetic data that's just as good,
Right.
that changes everything.
It changes everything because think about, you can run thousands of test flights in a simulator before you ever actually build a real plane. That's kind of what this enables you to do.
Yeah, and this could really democratize access to these tools.
Absolutely.
Because not everybody has the resources
Right.
to do this kind of real-world data collection, and it
Exactly.
levels the playing field in a way.
It really does.
So IntellAgent passes the reality check, it seems. But
Yeah.
what about the chatbots themselves? How did they actually perform in these tests? Did anybody ace the exam?
Well, there were no perfect scores.
Okay.
The results were mixed. And actually, one trend that emerged was as the complexity of the challenges increased, the chatbot's performance generally declined,
Okay.
which makes sense, right?
Yeah, juggling 5 tasks at once is harder than just focusing on one.
Exactly. It's harder for us. It's harder for the models.
Did they all struggle equally, though, or were there some star performers?
Well, that's where IntellAgent really shines, is it revealed that rate of decline in performance varied a lot across different models.
Okay.
So some were more robust and were able to maintain a higher level of performance even as the complexity ramped up.
So it's not just saying, okay, chatbot A is better than chatbot B. It's more nuanced.
Yeah, it's way more nuanced than that. You can now say chatbot A excels at following multi-step instructions, but maybe it struggles with like really nuanced user requests.
Yeah.
Whereas chatbot B might be really good at retrieving information very quickly, but it stumbles when it has.
Oh, our listeners got something to share. Let's hear it.
Hey there, sorry to interrupt. Can we make an example of this synthetic data?
Oh, absolutely. That's a great question.
Yeah, let's give you a concrete example of what that looks like.
So think back to our discussion about that retail scenario.
Right, where we mentioned the chatbot has to handle things like changing addresses.
Exactly. So instead of a real person making a request, IntellAgent generates a synthetic one.
So it creates a user who says something like, I need to change my default shipping address.
But it's not just that simple. The system also generates the context of the request.
Meaning it creates the initial state of the user's account in the system's database.
So the database might say, user A has address 123 Main Saint as their default.
Then the policy graph kicks in, guiding the AI to make sure that the user needs to verify their identity before changing the address.
And the AI creates a series of interactions that tests if the chatbot is properly adhering to that policy.
And to add complexity, it might throw in another request like, also show me my spouse's order history.
Which then checks if the chatbot can prevent unauthorized data access.
The key is the data is consistent, based on rules, not just random words.
So every part of the scenario, the user request, the dataways, the policy.
It's all generated by AI, but it's all structured and meaningful.
It's like a virtual play with AI playing the actors and even writing the script.
And that's how IntellAgent makes sure both diversity and realism.
Because that helped make it a little more clear.
Let us know if you have more questions, but let's get back to our discussion.
Yeah, so as we were saying, the models showed varied performance across policies.
Right. Some models did better with multi-step instructions, while others were faster at retrieval.
And this fine-grained analysis is what makes IntellAgent stand out.
It lets us see beyond just an overall score.
Right? It's like knowing your car's top speed, but also knowing how it handles in the rain.
Okay, so let's move on to part 3 and take a closer look at that retail scenario.
Yeah, so we've talked a lot about the potential of IntellAgent, but let's get to brass tacks.
Yeah, let's get concrete.
In part 2, we discussed how IntellAgent revealed differences in performance, especially on those user consent policies.
Right, those tricky user consent policies.
But the research goes further, walking us through a detailed case study.
A deep dive within a deep dive.
Exactly. This is a retail scenario where they put IntellAgent through its paces.
So they start with the policy graph, the framework for the chatbot's rules.
Think of that as the blueprint for the chatbot's behavior.
And they use prompts and database schema from a real-world benchmark, 10bench.
So they're grounding the rules in an actual retail environment.
And they identify key policies like modifying a user's address, retrieving order details, and verifying identity.
Tasks you'd encounter in real online retail interactions.
So it's not just abstract concepts, but real situations customers might face.
And these real-world policies are the nodes they use to construct the policy graph.
The connections between nodes represent how likely those actions are to happen in a conversation.
Like changing a user's address is linked to verifying their identity.
Right, you want to make sure it's the user making that change.
So the policy graph is not random, it's based on a realistic interaction.
Once they've mapped out the policy landscape, they generate events that challenge the chat guys.
These are the specific scenarios we mentioned earlier with synthetic user data.
Like that example where a user tries to access their spouse's order details while changing their address.
It's a great way to test if the chatbot is following rules and protecting sensitive information.
It's like a classic sitcom trope with higher stakes.
And the researchers show us everything: the user request, the database, and the user actions.
So there is full context for the interaction that's about to happen.
And that's when the virtual user agent enters with its instructions and event details.
The virtual agent plays the role of that mischievous customer, testing the chatbot's policy adherence.
And that's the ultimate test.
And the researchers include